We would like to be able to classify different linear systems based upon these three different terms: independent, dependent, or inconsistent. As you can see in the chart, the main things that I'm looking for are slope and y-intercept. Now, if you have two lines that have different slopes, such as the independent situation, they will cross one time. And it really doesn't matter. You can see that I put NA in here because it really absolutely doesn't matter to me what the y-intercepts are. They could be the same or different, but that doesn't really matter. What matters is that the slopes are different. As soon as I know the slopes are different, I know the two lines cross one time. Now, the other two different terms, dependent and inconsistent, they represent same line. So if you have two lines that sit directly on top of each other, then you wouldn't really notice that they were different, but they would have to have the same slope and the same y-intercept, which means they would be hitting every point identical. That means there's an infinite number of solutions, and I'm using the infinity symbol. Now, it does not mean any solution. Okay, that's different. Okay, there's lots of different points that are not on a particular line, but dependent does have an infinite number. Inconsistent means they are parallel lines. Okay, so we use that term, parallel, and they never cross. So they have the same exact slope, but they have different y-intercepts, and so you'll have no solutions whatsoever. So how do you classify these? Well, typically what I like to do is I like to make a little chart. I like to do my, and I showed you that trick in the last video of opposite of A over B to find the slope. So if I do that really quickly here, and I wish I could blow this up, because I think that is not enough room. And next time I'm going to do this differently, and I apologize. So the opposite of 3 over a negative 2. So we have a slope of 3/2 for the first equation. All right, so this is all under the slope category. Then on the second equation, I have the opposite of 6 over negative 4. Well, guess what? That's also 3/2. So we are either talking about dependent or inconsistent. We have just eliminated the last choice because we ended up with the same slope. So we're in one of these two categories. So now I have to go through the y-intercept. Well, according to what I showed you in the last video, the opposite A over B x plus C over B. Well, so that means the y-intercept is C over B. And if you do that for the first equation, C over B would be 7 over negative 2. And if you do that for the second equation, that would be 14 over negative 4. Well, those two things are exactly the same. So we are dealing with the dependence situation right here. Okay, let's see if we can get through these examples quicker. Same concept. So I see that they tried to trick me a little bit here. Opposite of 4x plus 16y equals 20. And, well, I don't know if this makes any difference to you, but we could really just simply divide that out and get y equals 1/4 x minus, if I reduce that, that would be 5/4. So here I have a slope of opposite of A over B. So the slope is positive 1/4, which matches that. So they have the same exact slope. And then I can do the C over B, 20 over 16, which reduces, 4 goes into the top and the bottom. Oh my goodness, 5/4. They are the same exact line. Once again, this ends up giving me the dependent situation. Okay? As you can see how I did this one, first thing I did was I switched both of these into I solved them both for y. And so I could easily graph. You know, you got a positive 3. First of all, hopefully you see that the slopes are the same. Slopes are the same, but the y-intercepts are different. Now, right there, that's enough information to say that there's no solution. But if you want me to graph it just to prove it to you, we'd have 3, and then down 2 over 1, down 2 over 1, down 2 over 1, and so forth, giving me that. And I'm sloppily doing the rest of that just because I already know the answer. and 6, and doing the same thing, down 2 over 1, down 2 over 1, down 2 over 1. So we're getting that same parallel shape. And be nicer if it had, if it was done nicer. In this particular situation, you can see I solved them for y, and what I ended up with was the exact same equation. So I know that there are an infinitely many number of solutions here. Now, the truth of the matter is they are infinitely many on y equals 2x plus 2. You can't just say any point in the world, but since we're dealing with multiple choice here, yes, you would definitely choosing that one right there. I don't even think you need to graph it, because I mean, I'm sure you can graph it if the question is asking you to graph it, in which it probably will. You can, then do your plus 2 and then up 2 over 1 and up 2 over 1, and get your line. It's the same line, so I'm like, it doesn't need to be done twice. As you can see in this question, I did a little rearranging on the top row because they had the x's and y's reversed, so that, trying to trick me up. On the second equation, I just went ahead and divided by 9 and reduced it, so I got y equals 1/3 x minus 7/3. Well, then when I did the opposite of a over b trick on the first one, opposite of negative 2 over 6, I ended up with 1/3 for the slope of this one. And when I did the c over b trick, 14 over 6, I ended up with 7/3. So you can see that they have the same exact slope, but they have different y-intercepts. Now, notice that one is positive 7/3 and one is negative 7/3. So they have same slope, different y-intercepts. That means they are inconsistent, right? Parallel lines, they never cross. Now you can work on your set 1B SWYK.